Hello, on this online presentation we're going to talk about disks, partitions, and volume management in Windows 10. So we have a couple of types of internal disks we should talk about. We have SATA, SCSI, and IDE. So SATA is, again, an internal way to plug in a hard drive, so it would be internal to the actual machine, be it a laptop or a desktop. Serial ATA, the ATA is AT attachment. So we're up to SATA version 3 as of this recording, and it does about 6 gigabits per second, which seems pretty fast, but again, relative to memory, it's relatively it's slow. SATA has pretty much taken over IDE, which was the one of the previous standards. Both platters, so talking about platters, both platters and solid-state drives can run SATA. SCSI is popular on more servers. It stands for Small Computer System Interface. And it's been around for a very long time. And again, it's just simply just a different way to connect it to the motherboard. It's often seen as faster and more reliable. That's why you see it on servers, but more difficult to configure. IDE is the older standard. It's going to have a bigger connection. You don't really need to know the difference of those. I just getting that out of the way. There are platters and there are SSDs. SSD is essentially just memory. It's banks of memory that is non-volatile. So when the power goes out, the data will be retained. While platters are metal platters that have read and write. We'll be talking about that, as you see right here. Heads that read and write the magnetic properties of the metal disk, and therefore recording whether or not there's ones or zeros. For external disks, we have USB. We're up to version 3 as well there, with faster transfer speed. Still nowhere near as fast as the internal disks. eSATA, which is external SATA standard, and Thunderbolt. And there's many other standards. But primarily we're talking about thumb drives and external hard drives. There's also virtual hard disks. Virtual hard disk is essentially, or VHD image as we call it in the world of Microsoft. A virtual hard disk is essentially a image of a hard disk. So it's the ones and zeros, and it's saved as a file on a hard drive. So it's a picture of a hard drive on a hard drive, or on some kind of storage. Okay. Again, it's the bits of the actual hard drive. You can mount it in an operating system. Microsoft, you can mount a VHD, which we will do, and that virtual hard drive, even though it's just a file, will look like another hard drive on to the operating system, or to the user who is using the operating system. And we have multiple disks versus one logical disk. Again, the term volume, a volume could be comprised of multiple disks. The disk is more referring to the actual hardware itself. So how do we organize these disks, and how do we recognize the systems on there, access the systems? Okay. Well, first of all, we need partition tables. We need to know what we can do is have partitions, which is a logical, when I say logical, we're going to have logical partitions versus primary partitions. So a partition is a way in which the operating system can, not physically, but logically, divide up a disk into multiple disks. We can partition out a disk and make it logically into multiple disks. All right. Most importantly, though, we have to have a boot partition. As we talked about in BIOS, the BIOS is one of the most, the biggest job for BIOS is to know where an operating system is on a hard disk, so that it can be booted up, so the operating system can then start loading into memory. That would be the boot partition. You can only have one boot partition. You can have multiple operating systems you boot to, but you're only going to have one boot partition, which then you would get a boot menu and decide what operating system you want to boot to if you have a dual boot or even a tri-boot. But you're going to have one boot partition. That boot partition is going to have the master boot record, which is the older standard. It has a 2 terabyte limit. That typically goes along with BIOS. And then we have the GPT, which is short for GUID, which is Globally Unique ID. Partition table, that's going to require UEFI interface. So GPT is for UEFI, MBR is for BIOS. All right, we're going to have primary and logical partitions. We don't partition as much as we used to back in the good old days. Back in the good old days, we partitioned quite a bit. Now we need more and more storage. So a primary partition is going to be a partition that particularly takes an entire disk. That'd be the primary, because you always have to have a partition. It's the logical allocation of part of the hard drive to the volume, if you will. So we'll stay with Microsoft. So again, we're going to have this issue where disk, partition, and volume becomes very interchangeable, and it can get very confusing. Okay, but even if we only have one partition, we need to partition. We need to define what that disk is. Okay, without a partition, there is no definition to the actual disk. So we can have a primary partition, which would be the partition. If you're only going to do one partition, it'd be a primary partition. You have to have at least one primary partition. You can also have logical partitions. Logical partitions will comprise of an extended partition and then logical partitions inside that extended partition. Okay, so that's in case you want to have one disk and many partitions on it. You would have one primary, an extended partition, which would not be the primary, but another partition, and then you could set up logical partitions inside the extended that could be then assigned drive letters to the operating system, or we'll stick with Windows. Then you'd be assigned drive letters. Okay, obviously with Linux you'd have mount points instead. So file systems, sectors, clusters, tracks. All right. So just know this. When we organize, when a file system is what actually has, as you can see, we have heads that go inside and outside here, right? These heads go back and they go forth, right? And you're going to have multiple heads and multiple sides of platters, okay? And what happens is it ends up sectoring out the entire disk. Okay, and somewhere along this disk we're going to have clusters. These sectors are going to be organized in clusters. Okay, not every single sector is going to store. In order to make sense of this, we're going to cluster up these sectors. They're all going to be uniquely, or not uniquely. They're going to be the same size, but we're going to cluster up the entire drive. Okay, so a cluster is a collection of sectors. All right. Now what happens is spinning platters have been hard drives for a very, very long time, since the 80s, okay? And these platters spin, and the head moves back and forth reading the data, all right, as it spins. So what happens is if we have a very large file that's written into a bunch of data here, what we want to do is set it up in a spiral pattern, like a track, like a record track, okay? We want to do that because that way the head doesn't have to keep, because if you had it the other way around, let's clear this, and if I had it the other way around and I had a bit of the data here, a bit of the data here, a bit of the data here, what's going to happen is this can only spin in one way, all right? And as it spins, I could read, maybe this is the first part, so I'd read this part, but if that's the second part, I have to wait for it to spin all the way around, then I'll read that. Then I have to wait for it to spin all the way around and read this third part, right? And that's going to take extra time. So what we try to do is we try to organize the data into tracks, and what this is called when you have your data spread out throughout the disk is fragmentation. Okay, back in the good old days, we had to defrag, as we called it, defrag our hard drive manually. Nowadays, file systems and operating systems defrag automatically. All right. Again, we're going to have this problem where disks and partitions and volumes, we're going to almost use them interchangeably. Volume is very popular in the world of Microsoft. A volume could be comprised of multiple disks or multiple partitions. There could be multiple partitions on a disk, as we talked about. Disk kind of breaks down to the actual physical thing. One disk is a physical disk. Okay, people will use them interchangeably, and it does add to the confusion. I'll do my best to be specific. A volume is more of a logical thing. So when I say the C drive, and that's just old terminology, I'm actually talking about the volume that is labeled the C drive, or C.
Okay. So let's talk about basic disks. A basic disk is partitioned and it's by either MBR or GPT. It has a drive letter assigned to it, and essentially it's one disk per volume, right? That's just a nice basic. I one primary partition on the entire drive, eating up the entire drive, and we format it with one file system. Well, we'd have to. You can only have one file system per partition. And we've assigned it a drive letter in Windows. That's a basic disk. Nice and simple. And we have dynamic disks. A dynamic disk can be comprised of multiple volumes, multiple disks, multiple partitions. We're going to talk about RAID in a little bit, a redundant array of individual disks. It's what it is it's a collection of disks that's either going to add to speed or redundancy, or both. All right. Drive letters used to help users identify volumes and systems. If I bring up my good friend, well, here we'll go here. We'll bring up PowerShell. Here's PowerShell. As you can see right here, I am in the D drive. I think I have an F drive. No, I do not. I haven't finished that lab yet. So I could go to different drives if I had different drives. Oh wait. Well, no, that's D. There you go. I'm in my D drive, which I don't know what that is. Oh, it's my CD-ROM. So there you go. I have a C drive, and why do you keep doing that? I got a C drive and I have a D drive. Okay, and I can go back and forth between the two of them. All right. Those are drive letters. Important for users to understand. Again, in Linux, we don't have drive letters. We have mount points. That's a separate issue altogether. All right, storage spaces. So later on in the world of Windows, they decided to storage spaces a very important deal when it comes to servers, and so what Microsoft did made it more dynamic would be the term, and elastic is another important term. We have multiple disks and volumes pooled together. There we go, pooled together dynamically. And it's good for NAS, which is network area storage, and SAN. This is for collections or depots of storage where multiple systems can get to that storage. Okay, we call them. We start off with a storage pool. The pool collects all these disks and volumes. And what happens is we can create once we create the pool, we can then assign it to its storage space. All right, and the storage space looks like just like a regular drive. The cool thing is, as long as no one's using a particular pool, we can take pools out or assign pools to storage spaces on the fly, and it will all be happening logically in the background. So just to let you know, there's this thing called storage spaces. It uses multiple disks and volumes. It can combine them all, and you can dynamically add and subtract from those, which is very important in an enterprise environment, particularly a server. Here in a desktop, if you had a desktop that had lots of different disks and you had multiple apps, databases, or something that took up a lot of space, and you wanted to dynamically switch between those, you could do that, although it's kind of unusual. All right, let's talk about RAID. RAID is when you have multiple disks. All right, so we have RAID 0, which is a striped disk. You have to with this you have to have at least 2. You could do it with multiple, more than 2, but normally, well, at a minimum you need 2. The way it works is this. We're going to use simple oversimplification of math. What we're going to do is, let's just say we had our data we wanted to use was 1, 2. All right. So part of that data, we're going to write it on disk 0 and disk 1. We're going to be 0 based. Okay. Now, the good news here, we don't lose any significant storage. When I say significant, there's a little bit of overhead, but for the most part, we don't lose any storage. If we have, like here, a 1 terabyte drive, we're going to do terabytes. If we have a 1 terabyte drive, and we got a 1 terabyte drive here, then in the case of striped here, we'd have 2 terabytes. Okay, we don't lose any storage, which is pretty cool. Why do you do this? For speed. Again, we talked about that, those country roads, slow country roads, just not a lot of infrastructure. Takes a while to get over potholes, mud, it's dirt road, whatever. It slows you down. It takes a while to read from storage. Well, if I have two of those slow roads, I can read from them simultaneously, and I can get that data a little bit quicker. That's why you do striped, is for speed. Okay. Next, we have RAID 1. All right, or mirrored. So we have striped is RAID 0, and we have RAID 1, which is mirrored. Mirrored, if we again, we're going to pick on the 1, 2. If we have 1, 2, we make a copy. We do 1, and we put 1, 2. All right. Now the advantage here is, there you go. If we lose a drive, we still have our data, 1, 2. We know what it is. On the striped, we don't. We lose the data. If we lose a drive, we lose the data. Data's gone, can't be recovered. Okay. With RAID 1, the data is, we have a perfectly good copy. The downside too is, going back to that terabytes, we got 1 terabyte here, 1 terabyte here. We only end up with 1 terabyte total, right? Because we make a copy of everything. So if we fill up this drive is going to be filled up with the same information. So we lose half our storage, but we get a copy of data each drive, so we have our redundancy. It doesn't give us any speed, but there you have it. That's RAID 1. Okay. And finally, for the basic RAIDs, there's much more complex RAIDs, but for this class, we're just going to do the basic RAIDs. We're going to do RAID 5, which is straight for parity. Oh, by the way, mirrored, you need to have 2 drives. I think that would be fairly obvious, but I didn't state it, so I'll say it. You need at least 2 drives, right? Because you're going to need 1 for the copy. RAID 5, you need at least 3 drives. That's why there's 3 drives here. Okay. We call that striped with parity. And the way it works is this. If we're going to go back to our 1, 2, we store part of the data here, part of the data here, and using the magic of algorithms and parity, we're able to create a third file that can be used to figure this data out. So if we lose a drive, I can sit there and say 1 plus x, again, I'm way oversimplifying it, equals 3. All right? And so then we're able to figure out that what our original data was. All right? There you go. Part of the data is written on each drive. It's redundant because we use that third drive. And it's fast too, right? Because if we're writing to it or reading to it, again, we can use those 2 country roads. We do have to create the parity file, but we do have speed when we're reading and writing to the drive. So we get speed and we get redundancy. But we need 3 disks, and we're going to lose a third of our storage, right? So if we have a 1 terabyte drive here, a 1 terabyte drive here, a 1 terabyte drive here, RAID would give us a 2. Well, that's a terrible 2. Let me work on that. A 2 terabyte drive, all right? Because we're going to lose a third of it for the parity. In the real world, the parity disk gets rotated, right? So the next time we write a file, let's say we're writing 24. Again, I'm way oversimplifying it. And at the end of the day, all data, cat pictures, everything is 1s and 0s, so we can use math. But we'd put part of the 2 here, we'd put the 4 here, and we'd put a 6 here, right? Oh, well, actually, so my whole point that I was trying to make, sorry, let me erase this, is if we had 24, right, we would put, maybe we'd put the 4 here, we'd put a 2 here. Did I go back and I made this the parity drive again? All right, next bit of data we'll do 36, right? So we'll put the 9 here, we'll put the 3 here, and we'll put the 6 here. Okay. Point is where the actual parity file is on these 3 disks will change periodically, but that's fine. People often say a parity file. I'm just letting you know that in the real world the parity file jumps around. So those are the 3 major RAIDs. We have RAID 0, which we call striped, RAID 1, which is mirrored, RAID 5, which is striped parity. You need 2 drives with RAID 0, RAID 1. You need 3 with RAID 5. RAID 0, you don't lose any storage. RAID 1, you're going to lose half your storage. RAID 5, you're going to lose a third of your storage. RAID 1 gives you speed, but you don't get any redundancy. RAID 1 gives you redundancy, but you don't get any speed. And RAID 5 gives you speed and redundancy. Okay, but you need 3 drives to do it. There you go. What we're going to do to use all this stuff for tools in Windows is we're going to use disk management. And if I right-click down here and I go to disk management, it might give me a warning. Nope. Okay. It's loading up. I have a lot of disks here because I did the lab, but here's the disk right here. Okay, this is disk management right here. Again, because it's an MMC, it has this overall view to it, a general format. It could be fit into the overall MMC, computer management MMC. It's a module in there, so you can get there as well. There it is. I might as well just take the full screen and grab this. There I am. So disk management MMC. It shows me here are my volumes. In this case, I have a disk that's been partitioned out. It's got the EFI, so that's how you know I'm running UEFI. It has the C drive, it has an F drive, or it has two partitions, right? In this case, I have two primary partitions, right? I have a partition here, and this one here is a primary partition that's also my boot boot partition too. So here you go. Here's disk 1. We have a mirrored drive right here, and we have a stripe drive right here. That's what we're going to set up in the lab. Okay. So there you go. There's disk MMC. It's not fancy, but it's powerful. It can initialize a disk. Before it's initialized, before disk is initialized, it'll be known as an unknown disk. You'll see that in the lab. We can decrease or increase the size of the partition. We'll do that in the lab. We can create or delete partitions. Obviously, we'll do that. We could format with different file systems. We're going to do that in a later lab because we're going to talk about file systems in general. By the way, also, if we see a disk that belongs to a different system, we can actually map to a different system. It's going to be called a foreign disk. All right. We could also use a tool called DiskPart. DiskPart can do anything Disk MMC can. It runs actually in DOS, so if I run, whoop, I got to get to my C drive. Actually, do I? It's probably path. Anyway, DiskPart, I can run that. It needs admin there it is. So there's DiskPart. It's very clunky to use. List disk, right? And I get all my disks. If I put like list disks, guess what? Don't get it. And then if I do right now list partition, if I type, there's no disk to select, so I have to actually select a disk first. So I do select disk. We'll select disk 0 because it has multiple partitions. It'll look nice. And then we'll do list partition. Okay. There you go. And now I can see my partitions. It's a bit clunky, I know, but it is powerful because we can use it in our scripts. So it's very useful in scripts, and it can do anything this MMC can do. There you go. So there we go with disk management. Windows 10, we talked about RAID. We talked about different disk types. We talked about basic hard drive function. One more thing I wanted to mention about this. When we delete a file in a hard disk, that's really the job of the file system, and we'll probably talk about this in the file system, but we don't actually delete the data on the disk, okay? The data, all we're going to do is delete the pointer in the file system. So say there's data, 1s and 0s in this particular cluster here. If we delete that file, we're not actually going through and scrubbing this and zeroing out, as we like to say, or changing all the magnetic properties. All we do is go to the operating system and say, all right, just forget about that file. So therefore, if you delete a file in an operating system using a file system, you can, in theory, go up and usually boot to a different operating system that can then mount this disk as not a bootable disk, or not booting off the disk. And it can go through and reconstruct all the files. So it can find your deleted files, FYI. All right, yeah, so we talked about hard drive function, and we talked about desktop technology. Any questions, feel free to drop me a line. Otherwise, I'll see you in the next online lecture. Thank you. Bye.